Hello, I am Professor Loda from Civil Engineering Department. We are going through this lecture series on water resources under elements of civil engineering, the first year subject we are discussing. This is part of one module out of the total part of elements of civil engineering carrying 10% of the weightage. My information is onto the screen. You could communicate with me through my email address if required. You could ask me any question through this contact information. As I said that we are discussing the fifth module of the elements of civil engineering. That is carrying almost 10% of the weightage, and we have already discussed a few parts of this module, that is the hydrologic cycle, their component, water use and conservation. Today we are going to discuss introduction to dams. Books on elements of civil engineering, as I said that there are a few books available. Textbook is by Tata Publishing House. Then there are few reference books available on dams and related water resources subject is the Engineering Hydrology by K. Subramanya. That is also publication Tata McGraw-Hill, and then Irrigation Engineering you could use as a reference by S.K. Garg, and publishers are from Delhi, Khanna Publishers. Today we are going to discuss dams, its definitions, what are the purposes of dams, then dam types, classification of dams, that is gravity dam or the earthen dam. So we are going to look into the classification of dams based on material used. Then we are also going to discuss little bit that classification of different types of dams based on size and height, and under that we would discuss large and major dams. Let's define dam. That what is dam? A dam is a hydraulic structure. Hydraulic structure means any structure built within the water or flowing water or stagnant water or structure holding water. So that part is we can call as the hydraulic structure. So dam is basically a hydraulic structure which slows the normal flow rate of river, say any channel carrying flow. So if we are going to obstruct it, then it would reduce or retard the flow rate in order to store water or divert water for turbines or divert water for irrigating the crops, or sometimes we need to divert the water to mitigate the flood risk in the channel or the cities, towns, villages on the banks of the channel. So that is basic purpose that we are constructing dams all over the country. We can again think about dam as a dam is a barrier that impounds water. A dam is a barrier or a wall kind of thing constructed. A dam is a barrier that impounds water and serves the primary purpose of retaining water. That water is retained onto the upstream side, means the river is entering into the impounded area, and the other area which we call as downstream side, which would remain almost dry if we don't allow water to go downstream. So that downstream portion of the dam would mostly remain dry. Dams are typically classified according to structure and material used in building the dam, or as per their size, height and capacity of the reservoir. it's a good statement about dam, that a dam is a cornerstone in the development and management of water resources development of a river basin. Think of any river basin that water flows in it. People withdraw water, but during the monsoon season, excess flows mostly flows to the ocean, making the water brackish, saline, and unusable thereafter. So what we can do that let's hold the water for some time and then use this water for various purposes. Purposes we would look at a later stage during this lecture, but the primary purpose is that dams are for the development of the river basins. We are constructing dams for the sake of development of water resources and at large to manage the water resources. Let's see the purposes for which dams or a particular dam can be constructed. So whenever we come across a dam, then the purpose of a particular dam may be one out of these, or there may be multi objectives of constructing a dam. Dams are constructed for a specific purpose, or for sometimes multi-purposes. Like first purpose is water supply. We could construct a dam for supplying water to towns or cities or maybe remote villages. So many a times the single objective, with this single objective we construct the dam and supply the water to the command area, to the area where there is need of water. So this is one purpose, important purpose for which we can go for constructing dam, that supplying water, because water may not be available during non-monsoon season to the towns or villages, and a water body is not available nearby. So what we do that let's create a barrier, impound water, transfer this water through pipelines or canals. That is called conveyance of the water from dam to a particular site where water is required. So what we call it as that dam is constructed for water supply. The second purpose may be like to control the flood. Many a river in India, in Gujarat, like Tapi, is subjected to frequent floods. Every 5 year, 10 year, we see that the Surat city is getting flooded. So what to do? How to protect Tapi river from getting flooded? So flood control is a major flood control is a major reason to construct dams. Like if dam is constructed, we could store water when there is excess rainfall. Then that rainfall can be stored in the reservoir, and when there is less rainfall in the area or in the catchment of the river, then that water can be transferred or released in the downstream side, or can be diverted from the reservoir to the canals or other areas. So flood control can be a very single purpose, or sometimes it is clubbed, and this purpose is clubbed with the other purposes of dam construction. Let's see what is the third, that irrigation may be a sole purpose of construction of a dam. Many dams in India are constructed for irrigation. What is irrigation? That artificial supply of water to the crops. Generally, we receive rainfall during the month of July, August, September, and these months, monsoon months, generally consider 4 months of monsoon. If the rainfall is not proper, not well distributed for the growth of the crop, or to supply the water during the Rabi season to grow the crops, then from where we supply the water to the fields, to the farmers to grow crops. So for that purpose, we need water for irrigation. We need to transfer the water to the fields to grow crop, to increase the productivity of the land for growing the crop. A crop may be like a kharif crop or rabi crop during the winter, or cash crops, or multi-season crops or vegetables many a times. So water need to be supplied to these crops, and to supply this, what we need, a system of irrigation, and primary structure for the irrigation purpose is the storage of water through construction of dam. So dams are constructed to store water for the sake of irrigation. Irrigation water would help in achieving self-sufficiency in food grain, in accelerating the growth in agricultural sector. Let's see the next objective. We have seen the water supply, flood control, irrigation. Next is the navigation. Navigation is mostly it is movement of ships to carry the cargo, to carry the goods through these channels. So dams are constructed. Dams are sometimes smaller dams, or such dams are created to have water depth so that ship can navigate through the water channel. So sometimes purpose is for the navigation. We construct such dams to increase the water depth to carry the ships. One more objective is the control of sedimentation. What is sedimentation? Sedimentation is like soil gets eroded during rainfall. When rain falls, then soil mass, the soft particles of the soil in the field or in the forest, that gets eroded and it flows with water. It settles down when the velocity of flow reduces, and it gets deposited, sometimes in the structure and sometimes where there is lesser velocity in the channel. So deposition takes place. That is sedimentation. Dams are constructed to check the sedimentation process or erosion process. Basically, dam would help in reducing the channel velocities. Nowadays, we hear that so many check dams are being constructed. So basic purpose of check dam is to check the soil erosion, and actually dams are also meant for this purpose. Last in purposes list is the hydropower generation. The need for power in India is tremendous. We are not self-sufficient. The thermal power, nuclear power, many other sources available. Hydropower, the contribution of hydropower is also quite big in total scenario of power sector. We could see that around 20% of the power is getting generated of the total through a hydro system. When we construct a dam, then many a times it is a secondary purpose to create the power generation through the energy of water. So hydropower, many a times it is the secondary objective, along with the water supply, or along with the irrigation, or along with the flood control that we are also generating. Many a times hydropower could be a sole objective if these dams are just small dams, or the single purpose, or power generation is not that high. Few megawatts are getting created. In that case, we call them the micro hydropower plants. So what we see that in the purposes list, many a times a dam could be a single purpose dam, or out of this list on a screen, a dam could be constructed for more than one purpose. If purpose of the dam construction is more than one, then we call that particular dam as multi-purpose dam or multi-objective dam. That particular dam can be called, and all the objectives need to be satisfied throughout the life of the dam. Mostly dams are constructed above 100 years of its service life. This particular slide I kept to make you aware that the share of hydropower, if you look at the left side pie chart, then you could visualize that the major contributor in the power sector is the thermal, and there is a quite big chunk contribution from the hydro also. 18% around is the hydropower contribution in power generation. Let's look at the different type of structures we can create as dam to hold the water upstream of. I would show you this case that how the water can be held in upstream side. But before that, let's understand some terminology used or the classification of the dam. First classification done basically is based on the structure and material that is going to be used in construction of the dam. So we can call a particular dam as gravity dam, earthen dam, rockfill dam, arch dam, buttress dam, masonry dam, or timber dam. And there could be many more in this same way. We could go particular material being used, then that particular dam would be called like this. What is gravity dam? If we are going to discuss these two first, that gravity dam and earthen dam, a little bit in detail so that you could prepare for examination. Basically, these are two important type of dams which are generally asked in the question paper of university, and different components or the functions of various components and how these dams are managed. Rockfill dam, arch dam, buttress dam, masonry dam, and timber dam, they are also important dams, but they are created for a particular situation. Like rockfill dam would mostly be created where rocks are available easily. Arch dam is constructed when there is a kind of foundation available, particular foundation available, so that it can carry the load of dam through the abutments, the side pillars where the whole dam is constructed. So a particular dam need to be looked at, that which particular material, which particular technique in construction of dam is going to be employed, and accordingly that dam would be built or at a particular location for particular to create particular capacity and a reservoir over there. Gravity dam. So we are discussing now, we are going to discuss two types of these dams, that gravity dams and earthen dam. What is gravity dam? In a gravity dam, mostly built with concrete, not necessarily with concrete, it can be with bricks also, but generally when we say gravity dam, then we think of that a dam is a concrete dam. What is it? The stability is achieved by its size and shape such that it will resist overturning, sliding, and crushing at the toe. Again, mostly built with concrete, stability is achieved by its size. That size, bigger the size, more would be the gravity force acting downward, making it stable to hold the water upstream. That is what is gravity dam, that we need to increase the size to make it stable, so that the gravitational force, that is force because of the weight mg, G is the component, that's why we call it a gravity dam. That mass of the dam into gravitational acceleration, what we get is the total weight, and that force, the weight is also force acting downward, making dam stable. So if we increase the size, it can store water appropriately and would make the dam stable, to would remain upright at a particular location where it need to be, and would store the water on upstream side. The dam will not overturn. This is a problem if we do not design it properly. Then this may overturn, like it's going just tilting towards downstream side of the channel. That the moment around the turning point caused by the water pressure is smaller than moment caused by the weight of the dam. The dam will not overturn. It would overturn if the water moment is more than the weight of the dam. So what we need to increase the weights to make it stable on the point. Where these gravity dams should be constructed, that is the site selection generally called in the dam engineering, that we generally go for a particular site selection. Channel could be 100 kilometer long, 200 kilometer long. Many times big rivers are like 500 to 1000 kilometer, like Narmada, Tapi, then Ganga. All are big rivers. And the dams, when we need to construct a dam on a particular site, then we are having possibility that a stretch of say 25 kilometer or 20 kilometers selected, and we look for a best site, so it remain intact for say 100 years, 200 years, or it's a intended lifetime. So a favorable site usually is one in valley, that is river valley, where the sound bedrock is reasonably close to the surface, topographical surface or earth surface, both in the floor and abutments of the dam. Floor, that is the bed of the channel, and abutments means the sides of the valley which can hold the load of the concrete dam. A concrete wall is going to be very large, very high, and a lot of load there going to be transferred to the bed of the channel as well as to the abutments, means the sides of the valley. So these two things should be very strong. So we look for such sites where it could take the load, or it can take up the load and do not get crushed, do not allow water to go down and hold it for its lifetime. So again I read it that a favorable site usually is one in a valley where the sound bedrock is reasonably close to the surface, both in the floor and abutments of the dam. The availability of suitable aggregate for manufacturing of concrete is also important consideration. Nowadays this is not, as transportation has become such easy that we could transfer material and concrete, but also many times become a condition, a restriction for us, that concrete if not available, material aggregates are not available to construct the gravity dam, then it would be difficult for us, or it would take longer time to construct the dam if we are transferring the concrete from one point to other point. Let's now discuss that how it would look like, that is the cross section of a gravity dam. Cross section of a gravity dam, I would show first you the next to next slide probably. This would be the type of gravity dam. This is a kind of cross-sectional view, please let that slide be, yes. This is the cross-sectional view of the dam. You look at that on the top there is a width, and then it is almost straight on the upstream side, that where water is there. Then on downstream side it is slanting. On upstream side, on the bottom there is heel, that is corner point is heel, and on to the right side there is a toe. So We could think of this, that this is heel, toe, and this is whole is the dam section. So I'll come back to this sketch again, but let's discuss a few points about the cross section of the gravity dam. A concrete gravity dam has a cross section such that with a flat bottom the dam is freestanding. With a flat bottom the dam is freestanding. It just transfers the load to the sound rock available there, but it's totally freestanding. The gravity dam has a center of gravity low enough that the dam will not topple if unsupported at the abutments. It won't topple. It should not topple, rather, if it is not supported at the abutments. What is third point? The gravity dam require maximum amount of concrete of their construction as compared with the other kinds of concrete dams. We could construct other dams. We have seen many types of dams with the help of material as concrete. But when we construct other like buttress dam, then the requirement of total concrete in those is less compared to the gravity dam, as this need to it be safer because of its own weight. Before going to show you that sketch again, we would look at that there are three basic safety conditions we need to assure about, and we also think as a design concept. These 3 points are design concepts, that dams shall be safe against overturning, that it should not overturn just from upstream to downstream. It is going because of the force, it's because of the moment of the water. It should not overturn. The second concept is that dam shall be safe against sliding at the bottom or at any stage of the dam, at the bottom where it meets the sound rock, or at any stage, because during the construction the dam is constructed in layers. Suppose the dam height is 100 meters, so 5 meters each, there would be 20 slices. At any section it should not fail in sliding. From the bottom it should not slide, go away, wash away into the channel because of the pressure of the water. And third, the dam shall be so proportioned that the allowable stresses in both the concrete and the foundation shall not be exceeded. That anywhere in concrete or in the sound rock, the stresses generated, that should not be exceeded beyond the permissible limit. Otherwise, there would be crushing of the toe, or crushing of the heel, or the foundation will get crushed. That situation should not occur. So we need to create such strong concrete work. We need to find such strong foundation so that foundation remains strong. The material of or the body of the dam remain strong because of the forces acting or stresses getting generated in the body or in the foundation. So this we can call them as design concepts. Now I explain you that what is where, because dam engineering is you might be new, you are first year student, you might have seen sketches in the school books, but let's look. This is the impounding of water. This is upstream here. This is dam, very flat, straight, vertical line, that is the upstream face of the dam. This is slanting downstream face. The bottommost here we call it as toe in case of gravity dam. This, the upstream bottom, we call it heel. This is river bed. This is river bed, and from here average line, dotted line drawn, and we measure the height of the water in the reservoir. This is full reservoir level. This is maximum water level in the reservoir. These are two different here, because many times we need to store more water during the monsoon season. free reservoir level. Sometimes there are gates fitted here onto the top, at the top, and if we close the gate, then we could some water here, additional excess water, which can be supplied for immediate purposes, and for long term the level maintained at FRL. Total dam height should be taken from bottom here to the top, and this is called dam section. Sometimes there is a hole here that is called drainage gallery, because certain amount of water also seeps through this concrete body, and we try to arrest that water which is seeping through this dam section into that gallery and allow that water to join the downstream side portion. These are some of the examples of the gravity dam constructed in India. We all are familiar in Gujarat that the Sardar Sarovar Dam is also called lifeline of our state. Construction would facilitate the drinking in many parts of Gujarat, North Gujarat, Saurashtra region, Kutch region, and it does irrigate lakhs of hectares land in northern Gujarat and Saurashtra region. The total height with the help of gates provided at the top, we have got now going to be 138.68 at FRL, that is in Gujarat. Bhakra is tall, very tall, 2 to 6 meter in Himachal Pradesh. The Indira Gandhi canal comes out of it, which irrigates parts of Punjab and Rajasthan, most part of the Rajasthan. Many districts it serves in Rajasthan. Then there is Lakhor Dam in Uttarakhand. It's under construction. Height is 192 meter proposed. Part of it is covered and is still going on. Many other dams are there, important dams. I just taken up example of 3. You could find and collect information about many other concrete dams in India for the sake of your assignment. This is one view of the Bhakra. Such views are available. Many parts are non-overflowing part, and there are few portion of the dam is the overflowing portion. Overflowing portion is called spillway. Spill water can spill over it. The excess water in the reservoir can be allowed onto the downstream side, and that is again joining the downstream of the channel, and water would flow downstream. Let's discuss these second types of dams, that is the earthen dams. Earthen dams are made from compacted earth or locally available material. Earlier we have seen that the gravity dam is mostly constructed with the help of concrete, or sometimes maybe bricks or like stones, but the total force acting on that, the gravity force, is the measure. Here we are not concerned with the weight of the dam, but what we are, that the soil should be compacted so that it won't allow water to seep through, or water is getting into the soil mass and allowing it to go downstream directly. That should not be possibility while construction and after construction. So earthen dams are made from compacted earth. Compacted earth, it is compacted, so compacted that it hold water upstream. With the help of many other things we do with the earthen dams, but what is measured, it is compacted properly with soil locally available, sometimes clay mixed with soil, so that material is used. Earthen dams are preferred for lower heights compared to the gravity dams. When say dams are to be constructed 15 meter, 20 meter, 50 meter, but not say we are going 100 or 150, 200, 250. If we are going for high dams, then we need to select a kind of gravity dam. But for lower height, these are economical, local available material can be used, and economically these are beneficial for lower heights. The length of such dams is generally larger than gravity dams. Gravity dams are basically constructed in the gorge, and These dams, the earthen dams, they constructed mostly can be constructed on alluvial reach of the channel or river. So the total length would be larger. You could see the second bullet that in case of Hirakund Dam, the total length Hirakund Dam, which is constructed on Mahanadi, is high as 26 kilometer, 26 kilometer total with all components of the dam. It's that much, 26 kilometers. This is the important point that seepage we are considering in earthen dam. When I would show you the sketch of earthen dam, we could make it out that what is seepage and how it, why and how we can control the seepage through the earthen dam. Seepage is nothing but water which percolates into the material of which the earthen dam is made of. So that water seeping through or percolating through the dam section is seepage. Sometimes this also seeps through the foundation of the dam. So that seeping water creates problem. It destabilizes the structure and causes failure of the dam. Many times such dams failed because of the improper control of the seepage. You might have heard that in Morbi, Machu Dam was earthen dam, and in 1979 the first part, Machu 1, was washed away because of the heavy rain and heavy seepage through the dam section. So such instances causes loss of life, loss of property. It should not happen. So we should scientifically understand what is the seepage and how it can be controlled through the dam. If dam fails, then it causes submergence of large area, large irrigation fields, and also many times towns, villages come under submergence. So that situation should not occur. We should be very cautious while designing earthen dam. We should do all scientific analysis before picking up a particular type of soil and giving it different dimensions, compaction method, compaction technology used in it. So what is seepage? Seepage through the body of earthen dam is a big concern and requires expert supervision to avoid failure of such dams. Two main components of the earthen dams are impervious to semi-impervious structure and the toy filter and dam, that we'll discuss in this while looking at the sketch of this earthen dam, that what the impervious core and the drain filter provided in the earthen dam. The purpose of the filter and drain is to provide a way for seepage to exit the dam without causing excessive erosion of the dam material. Since the dam material is soil or locally available material which got compacted, when there is excessive seepage, that material comes out, it gets detached and starts flowing with the seeping water, and what happens is that it causes gully effect or say piping or sometimes scooping out of the soil mass and causing failure of the earthen dam. So that should not happen, and we should avoid it. Earthen dam should be placed on an impervious foundation such as solid rock or clay. The requirement of foundation is not as rigorous as the gravity dam, but still we need to look for a very good solid rock or at least a good clay so that it can rest without giving much trouble of seepage through the foundation. Before giving you this slide, I show you this sketch of the dam section, earthen dam section. It looks different than the gravity dam. Gravity dam was standing tall, and the reason one is that the height of gravity dams is high, very high compared to the earthen dams. Second, the the upstream slope is almost vertical, it's a vertical, and downstream slope is also very steep. In case of this earthen dam, we have to keep the slopes gentle, as we are using the locally available material. So you look at both the slope. This upstream slope is one here, one vertical, 3 horizontal, and here downstream slope you look at 1 vertical, 2.5 horizontal. So these slopes are quite gentle. Upstream slope is more gentler compared to the downstream slope, and this is the core or the section body of the earthen dam. We have to put clay in layers, soil, local available soil here in layers. This is a cutoff provided. This is what is the mentioned previous foundation. This is what pervious foundation layer, and this is impervious layer, and we have to provide a cutoff trench so that water is not directly seeping from here and going down and creating piping. So we have to provide this cutoff trench, so it arrests the seepage down under this earthen dam into the cutoff trench, and it carries to downstream side through a system of drains. And this, the top line, here you look at the seepage line, and this is sometimes called phreatic line, top seepage line or phreatic line. And this is water level, this is a flooding water level, and in no case this earthen dam should be overtopped, in no case, because if any portion of this dam, earthen dam, if overtopped with the water, then there is no possibility of standing in position. It will get washed with, because here the material is loose and it will carry the downstream slope and ultimately failure of this. So flood level is this. If more water is there, then we have to construct the separate spillways to allow the excess water to flow downstream, and those spillways, overflowing sections need to be concrete structure. So that need to be provided, otherwise flood should be contained within this limit. And if water level is up to this full reservoir level, so water seeps through it, and it should be controlled, and it is going into this filter. This is downstream rock door filter, where water is allowed to accumulate and gets down and comes out at downstream side. If this phreatic line or top seepage line coming out somewhere here, then this the pressure force of this water, shipping water, would erode this surface and will cause the failure. So the section is different than the gravity dam in earthen dams, and the reasons why we go for such sections are what I explained just now. We have seen classification of the dams as per material used, as per structure or height, sometimes we call it. The dams can also be classified as per the capacity of reservoir, as per its height, only height, not as per the material. Let's see the height. So as per these two world organization, on a screen you would find the name. A classification by size, that dams are classified by ICOLD, that is International Commission on Large Dams, and WCD, that is World Commission on Dams, as large and major dams. These two are the governing bodies belonging to United Nations, and they classify the dams, also control the development of dams in various countries, various regions of this world. And they have classified into these two categories, that large dams and major dams. If dam height is more than 15 meter, below 15 meter, they don't call them large dams, they are ordinary or simple dams, small dams. Large dams, if height is going to be more than 15 meters, and the second criteria World Commission on Dam has taken, that if not only dam, barrage or say weirs, 5 to 15 meter you will find it on a screen that if the height of the dam is between 5 to 15 meter, but the total reservoir capacity, if it is in excess of 3 million, you look at this figure, 3 million cubic meters. The capacity of reservoir is measured in terms of cubic content of the water available. If it is crossing 3 million cubic meters, then that is also a large dam. In case of the height going beyond, say, 150 meter, then they are considered as major dams or major projects in terms of dams. So major dams where the dam height is more than 150 meters, they are classified as major dams. Looking at Sardar Sarovar dam, height is 138. It's very major project, but as per this definition, that is a lower than. Bhakra is going up above this, so that would be considered as a major dam. What we have discussed today is about the dam, that what is dam, how we could classify. As per the material used, we have discussed the gravity dams, then we have discussed the earthen dams. There are few other dams like timber dam, buttress dam. You could find all these examples in your book. A few sketches of the buttress dam. You could find also the various cross-sectional views of buttress dam or say arc dam. You would be surprised to see that the force, the total load transferred from these structure to bottom strata or the foundation or to the abutment is totally different for different dams and different materials used. And even in the small dam or large dam, the technicality of transfer of load or holding, we could say holding water upstream is different. So basic purpose here of the dam engineering or construction of dam is to store water, the cubic content. When we increase the height of the dam, say we are going 15 meter and above up to say 50 meter up to 100 meter, then it would cause the submergence of the area, submergence of the upstream area. Say Sardar Sarovar is standing, it is submerging land of the Gujarat districts, few Gujarat districts, and also causing submergence of few Madhya Pradesh states districts. So this submergence effect we always try to minimize. We create a kind of barrier, that is dam site, where the submergence is less. So that criteria need to be taken care of during the construction. There are many other factors where we look into, but since this is very introductory lecture, we are focusing mostly that the sectional views and how they are getting constructed, and then how could you utilize this knowledge of dam engineering in your discipline, maybe in civil engineering, electrical engineering, or mechanical engineering. Thank you very much.